Our group is ME21, and our project is detecting defects using vision technology.
A little bit of a background of our sponsor, Acutech Precision Aerospace. They're a global aerospace manufacturer supporting both the DoD and civilian markets. Some of their product lines include rotor and vibration dampening, engine and power generation, hydraulics, avionics, and actuation systems, landing gear and braking systems, as well as their rod end center. They have over 250 dedicated machining centers with over 500 employees. So, what does the current process look like? Acutech's current process for inspecting parts largely revolves around human inspection quality checks. These humans are 70 to 90% accurate on obvious defects and only 50 to 60% accurate on some finer defects. And of course, their accuracy decreases over time as they get fatigued. What we are trying to implement is a vision technology system that will not only be quicker and more accurate, but will have the ability to log data of the inspection.
So for our project, our problem statement was to design a quality inspection system that correctly identifies defects and classifies parts.
For all the components that we had to design, we started with concept exploration to see what's out there in the design space, and follow that up with hand calculations with strengths of materials, making sure that it wouldn't fail under obvious loads, and verify that through finite element analysis on ANSYS, and then follow it up through testing on the attribute agreement analysis. FEA and hand calculations were performed on all components we designed. Hand calculations were performed on simplified models of components, while ANSYS stress and deflection analysis was done on the full component.
After we completed our ANSYS analysis, we moved on to our camera inspection. After robot programming and camera inspection, we were able to decide which parts were good or bad. And on the left, you can see photos of the camera quality. And on the right, you can see it observing a not good part. And after that, our test results showed us that across the 5 parts, tested multiple times, we ended up with a 100% accuracy across the board, achieving our goal.
And after all, we can come together and make this final design CAD model where you can see our inspection system with the conveyors moving the parts to be inspected by the robot with the Keon's camera and then separated at the end after being inspected.